It's time! Hey guys, has cracked many jokes in this video. Do let us know your favorite ones. Also, there's a quiz at the end of this video. Don't miss it. Hey guys, have you met Bosco? If we had to introduce him, how would we do it? Not in dog language, We would say Bosco lives in house number 9. Barks only at 2 p.m. and absolutely loves to sleep. Similarly, what is carbon's identity? Probably an element that has atomic number 6 present in the second row of the periodic table. Boring. What is carbon here for? What is the importance of its existence? Do we need to summon Professor X for the answer? We literally would not be able to exist without carbon. It is that important. It is known to be present in some form or the other in every known life form on Earth. How? We all are made up of cells. Cells contain molecules, which contain atoms. Carbon is one such type of atom, but it comes in different shapes and forms. Ever been to the beach? Beach? Did I hear beach? Surfing time! Hold on, Almost everything that you see there, the rocks, the shells, even the ocean, contains carbon. Even a tennis racket, the lead of your pencil, your favorite fizzy drink, or even a sparkly diamond, they all have carbon. Looks like almost everything seems to either contain carbon or needs carbon to survive. But then, if carbon is so super high-level important, won't it get all used up? That's where nature steps in and saves all of us. It is constantly recycling carbon so that we don't run out. Just like a spinning wheel, carbon is also constantly circulating between living and non-living things. The cycle is called the carbon cycle. Now, we can further divide this cycle into the biological carbon cycle and the geological carbon cycle. The biological cycle can span from a few days to thousands of years, while the geological cycle can go on for millions of years. Let's first talk about the biological carbon cycle. The cycle starts with the autotrophs. Who are they? The cool guys who can make their food. Plants. Can you make your own food, Well, I can order my food all by myself. Does that count? Forget it. The cycle begins with the process of photosynthesis in plants. To make their own food, plants need carbon. This carbon is present in the air in the form of carbon dioxide. During photosynthesis, in the presence of sunlight, plants take in carbon dioxide. This carbon dioxide is then converted into glucose molecules. This is what the chemical equation looks like. Now, when we get a week's supply of food home, do we eat it up all at once? No. We eat some, we store some, right? Similarly, the glucose formed is used up by the plant for its activities or stored for future use. Now, what about us or even dogs, tigers, etc.? None of us can make our own food, so we either eat plants or other animals to survive. We are the heterotrophs. Who am I then? I only need burgers to survive. Anyways, when animals eat plants, the carbon content in the plants is transferred to them. Now, some animals like lions, tigers, etc. do not eat plants. But they do eat the plant-eating animals, right? When that happens, the carbon content enters their bodies as well. In this way, carbon enters all of us through the food chain. Now, time for the second half of the biological carbon cycle. As the sun rises every day, it also has to set. Similarly, the carbon that comes in has to go out. But how? Should I use a vacuum cleaner to suck the carbon out? No. When plants and animals respire, they release this carbon content into the atmosphere. How does that happen? When plants or animals need energy, they break down the carbon-containing glucose molecules through a process called cellular respiration. Just like we convert sugar to sugar syrup, this breakdown converts the trapped carbon into carbon dioxide, which is then released back into the atmosphere. This is the chemical equation of respiration. Also, when plants and animals die, they start to decay. Decomposers act on the dead organic matter, releasing carbon dioxide. Thus, the carbon content that was taken in by the organisms is released back into the atmosphere, marking the end of one biological carbon cycle. Yay! Carbon's going back to his mommy! Oh, some. Only you can say something like that. Now, let's talk about the other type of carbon cycle, the geological one. In geological carbon cycle, carbon circulates between air, water, rock, soil through processes like weathering, sedimentation, subduction, volcanic eruptions, etc. Let's dial down a little bit and understand step by step. In the atmosphere, when carbon dioxide dissolves in raindrops, it forms weak carbonic acid. This acidic rainwater, on reaching the Earth's surface, slowly starts causing the weathering of the rocks, forming carbonate compounds. Now, due to erosion, these carbonates are washed into the oceans. Then, they get deposited and start settling at the bottom of the ocean. Over time, just like a stack of pancakes, several layers of sediment accumulate on the sea floor. When conditions are suitable, large deposits of this sediment convert into rocks like limestone. Formation of such limestone rocks isolate or sequester carbon for millions of years in the Earth's crust. This process of capturing and storing carbon is termed as carbon sequestration, and the natural reservoirs like limestone rocks that store carbon are called carbon sinks. Now, when one tectonic plate of the Earth moves beneath another, the limestone rocks are pushed deeper into the Earth. This process is called subduction. What happens if we heat ice? It melts, right? Similarly, within the Earth, heat and pressure cause the limestone rocks to melt, releasing carbon dioxide from the rocks. Through volcanic eruptions, this carbon dioxide is released back into the atmosphere, completing the geological cycle. Besides this, due to human activity, a lot of additional carbon dioxide is being emitted into the atmosphere. How? Millions of years ago, many plant and animal remains containing carbon got buried deep into the soil. Just like I bury my secret treasure. Stop it, some. Within the Earth, these remains were subjected to extreme temperature and pressure for millions of years. Eventually, they got converted into fossil fuels such as coal, natural gas, oil, etc. Now, for most of our activities, like cooking, driving, etc., we use these fossil fuels, releasing the stored carbon back into the atmosphere. That's what I've been saying all along. Stop cooking. Start ordering. Stop it, some. Such human activities are affecting the carbon cycle. Due to Industrial Revolution, the demand for fossil fuels has risen globally. Just like eating food happens much faster than cooking it, fossil fuels are being used up much faster than they can be naturally formed. Also, as burning of fossil fuels releases carbon dioxide, it has led to elevated levels of carbon dioxide in the atmosphere. We know that plants absorb carbon dioxide and help in maintaining the carbon dioxide balance. Large-scale deforestation has thus contributed to the increase in atmospheric carbon dioxide. So, overall, nature has devised a great system of recycling carbon in the atmosphere, whether biologically through plants and animals or geologically through limestone and weathering. It is now our responsibility to maintain it. Which organisms release carbon from dead things into the atmosphere? Heterotrophs, autotrophs, decomposers, producers. Come on guys, clock is ticking. Start typing your answers in the comments section. The correct answer is option number 3, decomposers. Ready for the second one? Here we go. When carbon is captured and stored for many years, the process is called carbon subduction, carbon sequestration, weathering, cellular respiration. And your time has begun. Think fast and write your answer or correct option in the comments section. The correct answer is option number 2, carbon sequestration. Last question, guys. Good luck. Which process does not release carbon into the atmosphere? Photosynthesis, volcanic eruptions, weathering, cellular respiration. And your time has begun. The correct answer is option number 1, photosynthesis.